Hey guys, we are gonna continue on this systems of equations stuff with the next method. The next method that we're going to talk about is substitution. Okay, so substitution is another way to get the solution for a system. Right, it's a lot easier than graphing. There's one more method that we'll talk about after this. So substitution, what you have to do is you have to solve for one of the variables in one of the equations, and then take that and plug it into the other equation to make to give you something that you're able to work with. So you usually only want to use this when you have one of the variables in your equation that has no coefficient in front of it. So like that x in the first equation. Okay, if there's no coefficient in front of it, it's really easy to do. If there is coefficients in front of these other ones, you see these 2 and 3 in front of the other x's and y's, you could still do it. The only thing is you're going to be dividing, and so then you're going to be dealing with fractions, and that just is obviously a mess for everyone. So since this one is by itself, we want to manipulate this equation to get x by itself. Okay, so what we got to do is we got to subtract 2y from both sides, and the equation is going to look like this: x equals negative 2y plus 7, or 7 minus 2y, either way works. So now the substitution can happen. Basically what we do is we have this is all equivalent to x. So that means you could take that big thing and plug it in for that x. Okay, so this next step is going to be 3 times, parentheses, negative 2y plus 7 minus 2y equals 5. At that point, now we can solve for y because we've got an equation that has just y's in it. We know how to deal with those. So we'll go ahead and do that. Negative 6y plus 21 minus 2y equals 5. So negative 8y equals negative 16 when you subtract the 21 over. And y equals 2. Okay? If you guys need some time to check that, make sure you check your work and make sure you also get 2. Now, once you get 2 there, you can plug that 2 into any of the equations that you had and solve for x. So, in my opinion, it's the easiest to just use the original one. So we're just going to plug in. Well, I guess this one even makes more sense. Let's scratch that. Let's just go right up here and plug it in up there. All right, so x equals negative 2 times y is 2 plus 7. So x equals negative 4 plus 7. X equals 3. All right, so that means that the coordinates for the solution are 3, 2. Okay, so you can have the answer either as x equals 3 and y equals 2, or as this one coordinate, 3, 2. Either way, it works just fine. All right, so a couple other examples for it. All right, and this problem right here, we've got similar setup. All right, we have one of these, right? You're always looking for the one that doesn't have a coefficient, so you see this y right there. All right, that y has just a negative in front of it, so it's easy to manipulate that equation. All right, so if we add the 5x to both sides, we're going to have negative y equals, probably not use that color. That color's a little bit too light. Okay, negative y equals positive 5x, because you added the other side, plus 12. But the problem is we've got a negative y. We have to multiply everything by negative 1 to turn this into positive. So y equals negative 5x minus 12. Okay, negative 5x plus 12. Now, once you get that, take this, plug it in for the y in the next equation, and work it out. So we have 3x minus 5 times parentheses negative 5x minus 12, all equals 4. All right, now you see we've got an equation. It's a complex equation, but we still have just an equation with one variable, the x's, so you can solve that right there. We have to distribute this negative 5 before we do anything. So 3x plus 25x, because minus 5 times minus 5x is plus 25x, and plus 60 equals 4. Add stuff together, 28. X, subtract the 60 to the other side, we'll get negative 56, and so x will equal negative 2. Alright, once we get x equals negative 2, take it and plug it back in for the x to solve for y. So to do that, we'll have y equals negative 5 times negative 2 minus 12. So y equals 10 minus 12. Remember, negative 5 times negative 2 is going to be positive 10. And y equals negative 2. So the answer is going to be negative x equals negative 2, y equals negative 2, or your final answer could just be the coordinate, negative 2, negative 2. Right? So if you were to graph this on your calculator or on a coordinate plane on your own, if you graph those two equations right here, if you graph both of those, put them in y equals mx plus b, and graphed them, they would intersect at this point right here, negative 2, negative 2. All right, last couple problems we'll practice here. This one's a little bit more difficult because we've got no empty coefficients. All right, so since none of them are 1, and we have a whole bunch of fractions here, you're going to have to change the equations a little bit. All right, so what I would do is multiply this bottom equation by 2. All right, because if you multiply this bottom equation by 2, that 2 and the y is going to go away. Okay, and that's going to go away, leaving this y without a coefficient, which is perfect. That's what we're looking for. So when you do that, we got 4/3 x plus y, right? 1/2 times 2 is 1 equals 26. Now you can easily manipulate this. Everybody sees now that we have this empty y with no coefficient, so you can subtract the x to the other side, and you'll have y equals negative 4/3 x plus 26. All right, now from there, like I said, this is a little bit more of a complex problem. This is one of the harder problems. So with this, okay, you can take this and you can plug it up into the other equation for the y to solve for the y. So we'll have 3/8 x plus 3/4 times, parentheses, negative 4/3 x plus 26, all equals 12. All right, so we'll have to distribute our 3/4. And we'll have 3/8 x. Okay, 3/4 times negative 4/3 is just going to be negative 1. Okay, the 3's are going to go away, the 4's are going to go away, and you're going to have negative 1. So negative x. And you can solve for 3/4 times 26, and you will get plus, you're going to get 39/2 when you do the multiplication and you reduce it. You guys can check that at home. I promise it's right. Okay, that all equals 12. And the next part, okay, combine your x's, get the 39, get all the numbers to the right side, so you subtract this 39/2 to the other side. And we'll have negative 5/8 x equals negative 15/2. All right, and finally, last step, we got to get x by itself. So you could divide by this fraction, but dividing by a fraction is really the same as multiplying by the reciprocal. Right? We've talked about dividing fractions before, so you multiply by reciprocal. So we've got negative 8/5. Do the same on this side. Okay, we're going to do it to both sides. They go away. X is by itself. And we do this multiplication on the other side. Okay, you're going to get 3 times 4 is 12. Okay, the way that works, right, the 8 goes away and the 2 goes away, that becomes a 1, that becomes a 4, this goes away and becomes a 1, that goes away and becomes a 3, so you should get 12. Double check that at home, make sure that I got the right answer. So x equals 12 there. Now, once you get the x, plug it back in, find out what y is. So y equals negative 4/3 times 12 plus 26. All right, to get our y here, y equals, you should have negative 16, because the 3 this is like 12/1. 3 goes away and becomes a 1, 12 goes away and becomes a 3. Oh, sorry, 4. Okay, so you should have negative 16 plus 26, which equals 10. Okay, so x equals 12, y equals 10. Your final answer then could be the coordinate 12, 10. Once again, that's where the intersection would be if you graphed them. All right, last problem, the word problem. All right, in chemistry, you need 15 liters of 60% alcohol solution. You have a solution that's 50% alcohol and pure alcohol. Pure alcohol is going to be 100% solution. All right? How many liters of each should you mix together to get your solution? So you're going to need two different variables, right? You're going to need two equations, two variables. Now this is a pretty tough problem. Basically, you need to find your variables, okay? So we need an x, we need a y, all right? So how do you find out the variables? Well, you always look at the question, how many liters of each solution should you mix together? We have two solutions. So the 50% we can call x, and the 100% we'll call y, right? We need 15 liters total, so that means that x plus y, right, the amount of the 50% plus the amount of the 100% has to equal 15. So the first equation is x plus y equals 15. All right. The second part of it is where we need to add in the percentage to the solution. Okay, so the way you do that is we've got 50% of x, right, so 0.5 x, because 50% solution, plus 1 times y, right, because 100% is the same as 1, has to equal 0.6 times the total amount, 15. Okay, so if you look at what we're doing here, we've got concentration times liters plus concentration times liters equals concentration times liters, right? We've got the whole system of equations. I know this is a difficult problem, but I just wanted to do one of the harder ones so that when you get to this, hopefully you'll have some reference to go off of. So once you get this set up, that's kind of the hard part. You can really get it done quite easily from there. All right, so this one you could choose either of the variables because they both work out just fine. All right, well, let's go ahead and do y. All right, we'll solve for y, so y is going to be equal to negative x plus 15, right, because you subtract the x over. So that means you take this, plug it in for y, and we'll have 0.5 x plus 1 times, so you don't have to worry about anything else. All right, so it could just be a subtraction right away, right, because it's negative x minus x plus 15 equals 0.6 times 15. You can just go ahead and do that right away. You do it in your calculator or however else you want to do it. You should get 9. Okay, so 0.5x minus x is going to be negative 0.5x. So negative 0.5x, subtract the 15 over, we'll get negative 6. And so when you divide negative 0.5 to both sides, you should get x equals 12. Okay, now very easy to figure out the end of this equation, right? If you've got x equals 12, okay, so we got 12 plus what equals 15, so y obviously equals 3. And so the answer to this question would be you need 12 liters of the 50% alcohol and 3 liters of the pure alcohol. And you're done. Good luck, guys, and see you in class.